So when we talk about kinematics, okay, we are talking about the movement. Okay, movement through space and time. Okay, through space and time. Space dimension can be is a distance, right? Distance traveled, how long, how far, and time is time itself, how long, right? Well, how many seconds, how many minutes, and so on. And we know that the movement, the simple version of movement is distance equals speed times time, right? So when we are talking about the time or the velocity, velocity or speed, I just changed the speed by velocity. And then the d by s is the distance or the displacement. So v equals s over t, right? So ds over dt, when we do the derivative of the first s, so we have the s or we have the distance. If I want to derive ds over dt, we will get the speed or instantaneous speed, or a speed at a certain time. And if you go the second derivative, or d square s over dt square, you will get an instantaneous acceleration. Okay. As simple as this. If you derive s, you will get v. If you derive v, you will get a. As simple as that. Okay, so derive v, derive a. Derivative also. Okay, this is the main idea, and I don't have another way, another explanation, but if you want to make sure that you know how to derive, it would be like this. Remember, the ds dt is equals to limit h near to 0, right? And then s t minus s0 over t minus t0, or initial, plus minus initial. Okay, that's it. Oh, wait, no. st plus, st minus st plus h over, wait, I'm sorry, I forgot. Oh, there you go, here. T plus h subtract st over h. Remember this rule? This is the basic principle, or the first principle, yeah, of the derivative. Okay. First principle of the derivative. Okay. By the way, for the homework, it's only that, I think. Wait, yeah. I will put it in Microsoft Word and you can see later on. Now let's do for number 2 and 3, right? That's for your homework. Later on, we will discuss about how to do the derivative. I don't think question 2 needs to be done with easy or the harder derivative. Okay, so let's see number 2. It's quite simple. As long as you know the idea, moving particle in a straight line with displacement st equals 5 minus 2t squared, as simple as that, st, where t more than 0, of course. This is only for the formality. Why? Because time cannot be negative. Time can be 0, right? Find the average velocity from t2 to t5. Okay, so A. We have to find s2, right? And s5. So s2 is 5 minus 2 times 2 squared. Just insert this. 5 minus 5 times 5 squared, right? The distance or the position can be negative, right? So it's proven 5 minus 9 and 5 minus 8 equals negative 3. So negative 3 means it's on the left. And 5 minus 125. Okay, it's way further to the left, 120. So average velocity from t2 until t5, you just calculate the v, right? S5 minus S2, right? Or S2 minus S5, up to you. You can just find the gradient, the formula of gradient, remember? So the velocity equals to S5 minus S2 over T5 minus T2. S5 is negative 120 minus negative 3, right? Just insert the S5 and S2 here over 5 subtract 2. And negative 108, 617 over 3. So this will be in meter, cm over second, right? Look at the unit. Cm over second, negative. So it is going backwards. Why it is? Because it is negative. Wait, I'm finding my calculator. Give me a moment, yeah. Okay, negative 117 divided by 3. Negative 117 divided by 3 is negative 39. That's it. Now, find the average velocity from T2 until T2 plus H. See, you use the H rule. Limit H near to 0, and so on. Let's do B. So H can be anything, right? H can be 1, 2, 0 0.00001, 0 0.002, and so on. It can be too big or too small. It can be normal, right? But we know that to calculate the V is equals to S2 plus H subtract S2, right? Over, see, from 2 to 2 plus H, and then 2 plus H subtract 2, right? So S2 plus H, okay, what you need to do is try to put here. S2 plus H equals 5 subtract 2, 2 plus H squared. Do it super slowly. 5 minus 2, open the bracket. If you want to open the bracket, you can just write this. Do it slowly, use the rainbow rule for plus 2H directly, plus 4H plus H squared, right? And then 5 minus 8 minus 8H minus 2H squared. And then negative 3. Oh, everything is negative. I hate this. Minus 2 height squared. Not height, sorry. H. H is another formula. So negative 3 minus 8H minus 2H squared. Subtract S2. What is S2? S2 is, where the hell is S2? Oh, here. Negative 3. Right? Over H. Okay. So you can eliminate the negative 3 plus negative 3. And then you can eliminate the negative H as well, or H itself. You can get rid of the H. Negative 8 minus 2H over H cross. So the velocity, average velocity from T2 until 2 plus H is 8 minus 2H, right? Negative 8 minus 2H. There you go. Negative 8 minus 2H centimeter over second. That's your answer. In terms of H, of course. Why it is in terms of H? Because we don't have the value of H. Now we do question C. Find the value of this answer, also the same. See, it's the same. You look at this, but you need to change the H by almost 0. Okay, so you can cross this, and the velocity is negative 8 minus 2H itself. You don't have to do again and again. You don't have to do from the first. Okay, you find the answer here. And when H is near to 0, so the answer is negative 8 minus 2 times 0. So it is negative 8. Okay, so when H equals to almost 0, it means at an instant speed at T equals 2. Okay, that's hard. Okay. I have a hard time on having this kind of understanding. Interpret limit H near to 0 as T plus H minus ST over H. So this is the, what do you call, the guiding questions. So for leading you to do V, okay, to do D, I mean. So ST plus H, minus ST over H is an instantaneous speed at a certain value of T. instant speed at a certain value of t. Instant speed, not a fast speed, the instantaneous speed. For example, if I have t equals 2, like like the question gave you before, so we know that as t equals 5 minus 2t squared, how about vt? Just do the derivative, right? Going down.
Hans, what does
Yeah.
it say on the bottom screen? Instantaneous speed at what?
At a certain value of t, sorry.
Oh, okay.
So you just derive this negative 4t. Done. Let's do. How about if t equals 2? V2, right? Negative 4 times 2. 8. Negative 8, right? And it is proven for question C, right? When t equals 2. So, but we need to skip this first because the question is not asking you to do the fast derivative. This is the shortcut, by the way. So this is a shortcut when vt, so you just derive ds over dt, right? But again, this is only for the shortcut or for your what do you call it? Only for uh, confirming your answer. Okay, this is for number 2. Let's do later number 3 and number 4 and so on. Yeah, I think it will be quite interesting because if we do only number 2 and number 3 for the homework, it will wasting time. Nah, there you go. Velocity and acceleration functions later. Okay, let's do number 3. Then we can go next. Yeah. A particle move in a straight line with a velocity function vt. Oh, we have the velocity. Now, velocity going down to acceleration, right? Find the average acceleration, find the value, interpret. It's the same, but different in term. First, for number 2, s to v. Now, for number 3, v to t, right? So this is for number 2. This is for number 3, right? And it will be totally the same. Let's do. Okay. So vt equals 2 square root t plus 3, right? Find an average acceleration. So acceleration equals v4 minus v1 over t4 minus t1, right? v4, okay, just calculate 2 square root 4 plus 3, v1 2 square root 1 plus 3. So square root 4 is 2, 2 times 2, 4, 4 plus 3 is 7. 2 square root 1 is 2, 2 plus 3 is 5 also. Okay, just put it inside. 7 subtract 5 over 4 subtract 1, right? So 2 over 3 centimeter over second square, because the unit of acceleration is always distance over time square. The distance is centimeter, the time is second. Okay, just let it be. Now, question B. You need to find, okay, so A, VH plus 1 or 1 plus H. Okay, I just follow the order, minus V1 over, I think I need to put a bracket like this. Okay, T1 plus H minus T1. Okay, so
Wait,
V1
Baz,
plus H, yeah.
how did you get the equation of like v4 minus v1 over
Ah,
t4?
okay, from the physics rule. Do you remember? A equals or VT or V equals U plus AT. Remember this? Or do you use VT equals V0 plus A times T? Have you ever learned this in physics?
No, because I don't take physics. Well, we do, but we haven't gotten.
Yeah. Maybe it's too long already because it's 2 years before. So the formula of acceleration is this V final minus initial velocity over the time, the difference of the time. T means the second T is the last. This is initial. Okay, or I think this is better. Wait, I'm not using VT minus V. V2 minus V1 over T2 minus T1, and V also S2 minus S1 over T2 minus T1. Okay, this is the formula that you need to memorize. Yeah. Okay, this is the basic, so you know how to find the A or the V and so on as given on the first question, or like question number 2 also. Okay, get it, Vicky?
Yes.
Okay, so V1 plus H, what is it? So 2 square root 1 plus H plus 3. Okay, it's quite simple, but it's not as simple as what we can see like right now. Okay, so V1 plus H. So 2 square root 1 plus H plus 3 minus V1. V1 is 5 over 1 plus H, subtract 1, right? So 2 square root 1 plus H, 3 minus 5 is minus 2, right? Over, you can cross the H and you will get, hey, you can cross the 1, I mean, you will get H. That's all. If you want to make it more simple, okay, 2, 1 plus H, minus 1 over H. And it just another term, another display of the answer. So for question C, when H equals to 0, my goodness, how can we simplify this? When H is near to 0. Wait, if it is near to 0, we cannot cross any H at all, right? Oh, I don't know how to do. Wait, wait, wait. I have to think. B1, 5, right? Wait, give me a moment for question C. Okay, but I know the answer of D. Question C is supposed to be deriving this, right? How do you derive this? Let's say Vt equals to t power half plus 3, right? So if you want to do the derivatives, 1 over 2, 2 times 1 over 2, remember? 2 times 1 over 2 t power 1 over 2 subtract 1. So it is only t to the power of negative half, right? That's all. So it has to be something weird. I think the answer is 1. Okay. So for question D, wait, I just skipped question C. I don't know how to answer, but sorry for that. Interpret the limit of this near to 0. So an instantaneous acceleration at a certain value. Wait, what I'm writing? At a certain value of t. It's the same, but what is the difference? Acceleration. Previous question, instantaneous speed. Okay, so let's think of question C. Find the value of limit this when h equals to 0. We have the answer, by the way, here, but I don't think we can delete anything, right? Two, if I put 1 when h equals to 0, so 2, 1 plus 0 minus 1 over 0. Something wrong, right? If it is like this, so 2 times 0 over 0, this is 0 over 0, unknown, undefined. It is a prohibition for the limit. Remember, limit prohibition is 0 over 0. So what we have to make is try to annihilate the h somewhat. Anyhow, how to eliminate the h? That's the real problem, right? How do you eliminate this? I don't think I can help you in this question for C, yeah? But for D, it's the answer. Okay, I think I want to go further about this because I don't have the answer of this one passage. Oh, I see. I know how to do. So the h is always near to 0, right? So I can just interpret like this. I just do the what we call intuitively. So h is near to 0, so I can just write 1 plus 0.01 minus 1 over 0.01, and I compare with the other nearer to 0, to 1 plus 0.000001. I make it more complicated right now, 0.00001. You do the versus, and which is the more detailed? This is the more detailed, right? But again, you need to compare. Okay, let's do the calculation. Wow, I just thought about this. You don't have to use the crossing method, but you can do the intuitive method. Wait, I'm opening the calculator right now. There you go. 2 square root 1.01 on the first one, right? Then subtract 1 over 0.01. It is 100.99, right? So this is 100.99. How about this on the right side? I put another 0, extra 2 zeros, right? 2 0, 0, 4 zeros, yeah. And on the top also 4 zeros. And it is, wait, what's wrong? 100, wait. Is it something wrong? Wait a moment, please. Okay, I forget to put this. Girls, sorry girls. Put the bracket. See, because we have the bracket here. And I just ignore the bracket. Okay, you have to do that. You have to put on the bracket. Again, to 1.01 subtract 1, close the bracket over 0.01. The answer is 0.997. Okay, 0.998 for the rounding. Okay, 998. And if I put another 0, right, for the next, we do the versus. It is 0.999. So it's near to 1, right? It is near to 1. So the answer is 1. So what is 1? 1 meter over second, cm over second square. The acceleration at time t equals 1. Okay, now let's do, how if we do this? If t equals 1, right, t equals 1 as same, you just do this rather than you do the first thing. 1 over square root 1. 1 itself, right? So this is the simple way. So again, you need to avoid this for the first time. Avoid, okay? Because we are not doing this, by the way, unless you learn about the differentiation. Let's see on the book, on the next topic on acceleration. Here, velocity and acceleration functions. You need to memorize. The velocity is the derivative of s, like I said previously. And the acceleration is the first derivative of v or the second derivative of t, of s. See, it's the same. And every t as 0 is the initial conditions. Means when t equals 0, when it is about to start. Okay. So if st equals 0, p is at origin. When s equals more than 0, it's on the right. See, positive is on the right, negative is on the left, and v, positive is moving right, negative is moving left, and a, if it is positive, the velocity is increasing, acceleration, positive acceleration, and if a is negative, it is retardation or deceleration. Okay, I don't know what your teacher use, deceleration or retardation. It's the same. Okay, and I don't think we need to memorize this, but you know what is maximum or minimum displacement. See, optimation, remember? And constant velocity, maximum velocity, constant velocity when a equals 0. So this is the memorization of zeros. I don't think we need to use this. And there you go. Big S is speed, small s is displacement. You have to be very, very careful about this. Okay, so next. Okay, see this example later on. I will give you the example on question number 1. Okay, after we do question number 1, We discussed question number 1. I will give you time to do question number 3 and 4. 2 and 3, I mean. See, you have so much questions to be answered, but as long as you know the logic, the idea behind kinematics, it's very simple. The idea is only the first derivative of s equals of this, the displacement equals distance. No, equals velocity. The derivative of velocity will become acceleration. Let's do s given by st equals t squared minus 4t plus 3, right? From the origin. Find an expressions of for the object and draw sign diagram for each function. I don't think we need to draw sign diagrams, but question A, the v equals to ds over dt, right? The first derivative. So 2t minus 4, that's all, right? And A equals dv over dt to itself. That's all. No need to put the sign diagram because the plus minus is memorization. Find the initial condition. Initial conditions where the t equals to 0, right? Initial, that's the rule. So you have to find S0, V0, and A0, right? That's for the initial condition. S0 is 0 minus 0 plus 3, so 3. Interpret, what is this? So it's at the first position, is 3 on the right, 3 from, is 3 steps right from 0, yeah? 3 units, right? V0, you put V0, 2 times 0 minus 4, right? Here, you put here. So the first acceleration at first speed is 4 to the left. Okay, 4 unit over second, of course. Left, why? Because it's negative. A equals 0. A0 means E2 itself. It doesn't have to do, nothing to do with the time. So 2, constant acceleration, unchanged during the time, by the time. So when the time is increasing, the A remains the same too. Okay, describe the motion at T2. Okay, the motion at T2, motion means you have to find S2 at what position, V2 at what distance, what speed, A2 at what acceleration. S2, just insert 2 square minus 4 times 2 plus 3, 4 minus 8, negative 4 plus 3, 1, right? Negative 1. So negative 1, and interpret negative 1, 1 to the left, right? So V2, just put this 2 times 2 minus 4, oh, 0. So it is resting for a while at V2 equals 2. It stopped for a while, and A2 still 2 because remains the same, constant. Okay, at what time does the object reverse direction? Reverse direction, it means reverse. You change the direction. So when it is reversing the direction, it has to be stationary, right? Remember stationary from going up to going down, or from going down to going up. So the ds over dt equals to 0, right? So the ds over dt equals to 0. We have the answer right already, right? When it is 0. Or if you don't, if you're, okay, I don't believe in question C connected with question D. So we know that it's a stationary point, reverse direction. You change the direction, change the speed. So from positive to negative, of course. So 2t minus 4 equals to 0, right? Just put it here. So 2t equals 4, the t equals 2. See, it's proven when time equals 2. At what time when t equals 2 seconds? Draw the motion diagram for the object. So the motion diagram will be like this, the S and T, right? So it is changing the direction. Oh, the V and T, sorry. Motion means the movement, V and T. So when when T equals 0, the V is negative 4. It starts from here, right? The speed is is negative to the left, and it has to be 0 on 2, right? This is 1, 2, and it is here. And the motion diagram will be like this. the VT diagram, yeah. There you go. Okay, it's a straight line because it is a constant acceleration. Okay, at what time intervals is the speed of the object decreasing? If you can see for the question F, wait, the question F is actually asking you to interpret the E, the question, the graph. For what time intervals is the speed of the object decreasing? Decreasing means from fast to slow, right? At this time interval, as you can see, easy. Decreasing from fast to slow. There you go, at t equals 0 until 2. Okay, if 2 to the next part is increasing, right? So it is increasing speed. And this will be decreasing speed. From -4 to 0, right? To 0, nearer to 0 is decreasing. So when they're decreasing from 0 until 2, right? From t 0 until 2, because the velocity is from -4, 4 to the left until 0, right? That's the idea of decreasing function. Okay, that's it. I will send this to you. It's quite hard, especially for question D and above. Okay, for this question D and above, it is quite complicated, but you know how to do right now. Reversing the direction and so on. Okay, so let's do for number 2. Number 2 is, I think it's more simple than number 1. As long as you know the logic, and I will explain to you later on. Yeah, I will give you time to do this, to think about this, about 5 until 10 minutes. Give me a moment. I will pause the recording. So for this kind of question, you need to find the velocity and acceleration functions. So the question A, it's quite simple. VT is the derivative of S, 98 subtract 9.8, right? This is 9.8 T. And then the AT will equals to -9.8. And it is a constant, right? So question B, find the initial position and initial velocity. Okay, so S0 and V0, that's the question. Okay, so S0 is 0, right? Because 98 times 0 minus 4.9 times 0 squared. And V0, 0 also. Oh, no, sorry. V0 is 98, right? Put here. I almost forgot. I think I put it here. 98 minus 9.8 times 0, so 98 meter over second. This is meter, right? Describe the stone's motion at time t and time 12 seconds. So motion, it means you need to find the V12 and V5, right? I think you can do it easily, right? At t5, what does it mean? So the velocity is moving, blah blah blah, right or left, I don't know, I don't calculate this at all, but again you just substitute it here, right? And you get the answer.
When we're looking for the motion, we always use the velocity. Yeah.
The motion is always velocity or not? Wait, good question. But I think, okay, see, yeah. Oh, everything. Oh my goodness, everything. Describe the motion at t2, so you need to find everything. Yeah, insert.
Okay.
So when t equals 2, the particle is 3 meters to the right and moving 9 centimeters over second to the right at an acceleration of 12 cm over second square. Everything. Thank you for reminding.
For the equation for acceleration, would it just be like a2 minus a1 over?
No. Why? Because the a is constant. Yeah, there you go. If a is constant, a2 and a1 is the same, 9.8. Sorry, -9.8. Got it? Oh man, this is so annoying. When t equals 5 and when t equals 12, you have to find the s, v, and a. The a is unchanged, just write like this. So let's do this. Okay, do it slowly. When t equals 5, the s is 98 times 5 minus 4.9 times 5 squared. Bang. 367.5. And 12, you just change the 5 by 12. Here. Thank you, Vicky, for reminding, because sometimes I often underestimate the question. 470.4. Okay, and do the V. The V is 98, subtract 9.85, right? Times 5. 49. Oh, meter, yeah. Okay, meter. And then put the 5 becomes 12. Fine. Negative 19.6. So for question C part, when t equals 5, you can determine. So I just type it. At t equals 5, the position of an object is 367.5 meter to the left, right, because it's positive, and moving with speed 49 meter right, meter over second, right, with a constant acceleration of negative 9.8 meter, meter over second square. Okay. I think I need to put enter. There you go. That's 4 at T5, right? How about if T12, you do it on your own, wasting time. 470.4 meter to the right and moving with speed 19.6 meter over second left, right? Because it's negative, with a constant acceleration of negative 9.8 meter over second square. Okay, that's it. B, maximum height. So as maximum, right? S is height, right? Vertical projection. So X max is a stationary. Remember? Stationary. So it means ds over dt equals to 0. Or the v, you don't have to derive one more time because you already derived this. 98 minus 9.8 t equals to 0. So we can find t easily. T equals 10, right? So when t equals 10, it changed its direction. So bang. Going up, going down, vertical, right? So at t equals 10. So you can see that it's logical. When t equals 5, it's still going upwards, right? The velocity. When t equals 12, let's say here, t is negative, right? So it is proven with this idea, okay? And then after d, find the maximum height at t equals 10, because it cannot be more higher. It cannot be higher than this because it's turning point. So as 10, right? Insert 9.8 times 10 minus 4.9 times 10 square. So 98 minus 49. Oh, sorry. 980 minus 490. So 490 meter is the maximum height. If you don't believe, later on I'll try to prove it to you. Okay. Find the time taken for the stone to hit the ground, E. So the time taken for the stone to hit the ground. To hit the ground is when as t equals to 0, right? When the position is 0, back to the ground. So 0 equals 98t minus 4.9 t squared. Right? This is a regular So first, when t equals 0, or the second, when 98 minus 4.9 t equals to 0, the t is 20 then. Okay, just use the algebra. Now let's try to prove with the GeoGebra. That's what I'm waiting right now. Do this with algebra. Wait, no, we do this with GeoGebra. Geogebra.com. So we use the S and the Y and X, yeah, not S and T, because GeoGebra cannot read that different X's. They cannot determine what is S, what is T. So you have to make in from Y equals 98x subtract 4.9x squared. The maximum part is 400 something, no, yeah, 490, see? So you can imagine that this is the projection of the image of the object that is thrown upwards from ground with a certain velocity, with the initial velocity of, wait, the initial velocity is V0 is 98 meter over second square. It's so fast. Can you imagine 1 second can travels 98 meter? So it is being pulled down by the gravity until it is slowly, slower until maximum height, and it is going down, right? So from here, with the super fast speed going up, bang, and then going down. This is the time taken, 20, see, 20.0, 20,0. So the time taken for, this is the t axis, and this will be the v axis. Yeah, this is the t axis, and this is the s axis. Yeah, not y and x anymore, because we deal with the word problem. Okay. Any questions so far, girls?
No.
Okay, still understandable, right? So you derive s becomes v, you derive
I
v.
just have
Sorry?
think I just have a hard time of picking like to use S, T, or
Okay. So this is not as hard as previous homework, guys, girls, because the previous homework, I don't know why your teacher just shuffled the order. 14.2 done here. Optimization is on at E, right? See, why on earth your teacher give you this first and then go back to the easier one? I don't know, but maybe your teacher give you the hard time first and then the easier will be following. That's good also. Okay, now we learn. I will send you the files, kinematics. Tedra, do you have any question?
No, I don't think so.
Okay, nice. So Vicky, if you want to have lesson with Tedra for next meeting or Thursday, just let Tedra know and let her decide. Yeah. So I think that's all for today. We still have 3 minutes. So this will be all of the workings that I will send to you. And also the video will be uploaded later on, okay, for the kinematics and derivatives.